Hello and welcome. If you're new here, my name is Joe and I rant about the things that I think we need to do to prepare for the coming effects of climate change. If you've been here before, welcome back. This video is part 2 in a 3-part series on how to build the houses of the future. In part 1, I covered how we currently build houses today. In fact, here is the schematic that I showed at the end of that video. I went through and explained all these different components that make up a house today. In today's video, I'll go through what's wrong with the way we build houses today. And part 3 will be about, I'll present an idea for how I think homes of the future could be built that address all of these issues and achieve 3 goals that I laid out in part 1. And that is, houses should be a lot more durable. They need to be able to withstand much more extreme weather conditions like those that we will be facing in the future. Another goal is that homes of the future should be off-grid. They should be able to exist without being connected to a power grid or even a water source. And thirdly, homes of the future should be made from recycled materials. We generate way too much garbage, way too much plastic, and I don't see why we shouldn't turn some of that stuff into the housing materials that we use in the future. So here we go. What is wrong with the way we currently build houses today? I was trying to figure out the best way to organize this information for this video, and I came across some survey results by the International Association of Certified Home Inspectors. I think I said that right. I found this on a website. I'll put the link in the description below. 10 most common house problems found by US and Canadian home inspectors. So I'll do this David Letterman style and go backwards 10 to 1. So number 10, miscellaneous. This category includes primarily interior components, often cosmetic in nature, which were not found frequently enough to rank individually in our survey. So I could have even just skipped that, but if I just said top 9, you would wonder, well, what's number 10? Number 9 is poor ventilation. Perhaps due to overly ambitious efforts to save energy, many homeowners have oversealed their homes, resulting in excessive interior moisture. This can cause rotting and premature failure of both structural and non-structural elements. So in part 1 I mentioned if you're going to have a ceiling fan in your bathroom, it needs to vent out to the outside. It has to go through the roof or out if you have maybe it vents off through the siding. But you cannot vent it into the attic space itself. If you have a house that doesn't have a ceiling fan in the bathroom, you might install one and then realize, all right, well, I got to vent this somewhere, and the attic is huge. Why don't I just send it up here? It'll just mix with all this. The attic goes the entire length of the building. I mean, the bathroom is one small room. What's the harm in just sending the air up here? And most of the time, it's probably okay. The issue is, and I need to explain a little bit about relative humidity and temperature and dew point before I go any further, because people need to understand what these numbers actually mean if you're going to do any do-it-yourself work to a house. So the dew point temperature is also called the saturation temperature. That's the temperature at which, if the temperature and dew point were the same number, you would have 100% relative humidity. Now that's probably how it was explained to you back in 9th grade earth science, and that was a definition that kind of makes sense. But I first want to explain something called absolute humidity. I think that'll make this a little easier to understand. Absolute humidity is the measure of how much water vapor there actually is. So the thing about absolute humidity, or the amount of water vapor in the air, is that there's a limit to how much water vapor there can be at any one time based on temperature. So the way this is measured is in grams per cubic meter, or grams per kilogram of air. It's the same thing. So if you have a cubic meter, obviously this is not a meter, but if you have a cubic meter of air, the amount of moisture or water vapor in that air might range anywhere from 0 to 30 or 40 grams. But again, how much can exist is dependent on the temperature. The higher the temperature, the more water vapor there can be. The reason for this is the way a water molecule is actually shaped. It's H2O, two hydrogens, one oxygen. You got the oxygen in the middle, and then the two hydrogens off to each side. Now, oxygen is a lot bigger than hydrogen, so it hogs up the electrons from the hydrogens. And so, since electrons are negative, and oxygen is going to have two extra ones most of the time, you get this point here that's like negative, like the end of a magnet. And then the two hydrogens don't have their electron most of the time, so that leaves them as positive. So you get these two positive ends, and so they act like little magnets floating around. Temperature is actually a measure of the average kinetic energy of a substance. That sounds complicated. Kinetic refers to motion. So it's just how fast is everything moving. The higher the temperature, the faster things are moving. Now, obviously, the molecules on your stovetop can't move because it's made of metal. But things can move in one of three ways. They can actually move laterally, they can vibrate, or they can spin. So anyway, a water molecule in the air is going to be doing all three. So the higher the temperature, the faster on average everything is moving, and so there's a less likelihood that when any two of them bounce into each other or bounce into something else, that they'll stick. They have enough momentum that they'll bounce off. But if you lower the temperature and you have all this water vapor floating around, they're not moving around as much. So now you have these magnets that are moving a bit slower, and they start sticking to things until there's fewer of them that can move freely without bouncing into each other so much. I guess that's one way to explain it. So anyway, the absolute humidity in grams per kilogram, that's how many water vapor molecules are there if you could actually weigh them. So now the way this relates to temperature is that sets that maximum limit. So at 50 degrees Fahrenheit, the most amount of water vapor there can be is 9 grams in 1 cubic meter. If the temperature is 86 degrees Fahrenheit, the most amount of water vapor that there can be in this cube of air is 30 grams. So, now let's say there actually is 9. Let's say it's 86 degrees out, and there's 9 grams of water vapor per cubic meter. So, the dew point temperature refers to how much there actually is. So, if the maximum for 9 grams equates to 50 degrees Fahrenheit, then when there is 9 grams, that's the dew point. The dew point temperature is 50. And the actual temperature in this example is 86, which can have up to 30 grams. 9 grams divided by how many you actually have, divided by 30, how many you could have, is 0.3. 30%. That's the relative humidity. That's where that number comes from. It's the absolute humidity of relating to how much water vapor there actually is, divided by how much there could be. But that's way more complicated than anyone wants to think about, so we just use relative humidity. But just understand it's relative to the temperature. Dew point is a way of telling you how much there actually is. The higher the dew point, the higher the dew point, the more water vapor there actually is in the air. So if that made any sense, let me go back to this moisture example in the attic. So let's say downstairs in the living space, you have it set to 70 degrees. It's 30 degrees outside, and you go up into the attic and measure that the temperature is 60 degrees and the dew point is 45. But you pay attention to the temperature. You're like, oh, it's 60 degrees up here. I don't mean to be heating up my attic. I want to heat just the living space. So you want to cut down on your electric bill, your heating costs. So you insulate the floor of your attic, or you add more insulation if there was some already. You add more insulation, and maybe you put down a sheet of plastic and staple that to all the floor joists. So you improve the thermal barrier that was described in part 1, and you have improved or established a pressure barrier. So now you're happy that, all right, there should be way less heat making it from downstairs up into the attic. So after you do this work, you go upstairs and check. Same conditions, 70 downstairs, 30 outside, but now it's 45 degrees in the attic. And you're like, okay, great. My electric bill will definitely be lower. It's definitely cooler up here. The problem is The dew point is still going to be 45 if you keep sending moisture up there on a regular basis. So the relative humidity could now be 100% or close to it. Now, you didn't add any more water vapor than there previously was. You've lowered the temperature. So in that relative humidity fraction, you haven't increased the numerator, you've decreased the denominator. So when that happens, as cool air comes in through the soffit vents, now the inside of the plywood, the inside of the roof, you have cool air coming in contact with moist, warm air. It's going to begin to condense like taking a can out of the fridge. You put it on the counter, you leave for a couple minutes, you come back, and there's droplets all over that can. Where do those droplets come from? From the surrounding air. That can chilled the air around it and forced condensation to occur. So the same thing's going to happen over by those soffit vents, and you're going to get moisture on the inside of that. Not that you're going to be able to notice until mold or mildew actually begins to grow. But also, when are you going to catch that? How often are you going up in your attic and looking for that problem? In fact, if anything, you're thinking, well, I previously didn't have a leak, so I know my roof is good. And now that I have improved the thermal and pressure barriers, I have now, I've added that insulation. I've added that plastic sheet. The attic should be in great shape. Well, eventually you're going to find a mold problem up there because your first instinct might be, oh no, now I have a leak. No, you don't have a leak. You've over-insulated relative to the fact that you're adding moisture. So you need to vent that out from the bathroom and not be sending it up there, or that's what you're going to end up with. Homeowners, when they buy a house, they're not handed a user manual. It's not like, here's how to use the house, here are the things to look for. And that's not the purpose of a home inspection. A home inspection is to identify any problems, not to tell you what to keep up with on a regular basis, and so people don't. And so houses fall apart over time. We just accept this as the way it is, but it's because homeowners are almost set up to fail. Because we've made things so complicated for ourselves, just because of the materials that we use, and the fact that we don't fully finish building houses in the first place. When you buy a house, it typically does not come with a finished attic. Typically won't come with a finished basement. It's just standard not to do that because based on the way the real estate market works, the builder's not going to be able to sell it for any more if they do that. So anyway, that's a whole other story. That was a long-winded thing about going into poor ventilation. That should be the only rabbit hole I go down in this video. Number 8, exteriors. Flaws in a home's exterior, including windows, doors, and wall surfaces, are responsible for water and air penetration, but rarely have structural significance. Inadequate caulking and or weather stripping are the most common culprits. So this just gets into having doors and windows that don't leak, especially doors. Over time, as the house is swaying in the wind, as the house is settling, one of the issues with building a wooden frame with softwood, if you have a nail and a piece of wood and you push them against each other, the wood is not going to dent the nail, but the nail will dent the wood. So the hole that the nail is created when you hammered it in, over time it starts getting loosened up. So more and more over time, things in homes become less perpendicular or less squared. That includes door frames that might tilt a little bit, and if they're not plumb, meaning they're perpendicular to gravity, you might have some, in an old house, you might have doors that when you open them, they close back a little bit. Or if you don't close it all the way, you close it most of the way, they just open right back up again. It's because there are things in the house that are now a little bit askew. They may have been fine when the house was first built, but anyway. And when it's an exterior door, that's going to cause leakage. Air is going to get around it. You definitely don't want moisture getting around it. Especially with the windows. You need to use good caulking. It's going to last a long time. Number 7, plumbing. Though not ranked by the respondents as a number 1 problem, plumbing defects still rank high among the house problems encountered and include the existence of old and incompatible piping materials as well as faulty fixtures and waste lines. So, in terms of old pipes, that would include lead pipes. I mean, look what happened in Flint, Michigan. And that's an extreme example, but it's also not as uncommon as you might think. Incompatible also refers to Some plumbers like to use copper pipes, some like to use PVC, and there can be a mismatch of things throughout the house. Even the way the fixtures are put together. And as far as the fixtures go, with my house, I have a well. I don't have municipal water. So I need a sediment filter to keep sediment from coming in and gumming up stuff in the plumbing. Which happened, the previous owners, their water filter, the sediment filter broke. They just let it go. And so my showers, the showers that I have, was the big dial. So there's like a gadget in there that however far over it's turned determines how far the cold opens, how far the hot opens. There's little springs in there. And those are all gummed up with sediment because of a lack of maintenance or a lack of fixing the sediment filter by the previous owners. So it's easy to let things go. Sometimes people do it unknowingly. It's just an innocent mistake. Sometimes things are just obvious and right in your face, but people are broke and they don't get around to it. One way or the other, a lack of keeping up with home maintenance really does a number on a house over the years. Number 6, structurally related problems. Many houses, as a result of problems in one or more of the other categories, sustain damage to such structural components as foundation walls, floor joists, rafters, and window and door headers. Headers are the boards that, the beams go right over the opening of the doorway or window. So basically what this is getting at is structural problems that result from not fixing things. One problem leads to another problem, leads to another problem. All right, number 5, poor overall maintenance. Even the novice home buyer is usually aware of this situation, demonstrated by such signs as cracked, peeling, and dirty painted surfaces, crumbling masonry, makeshift wiring and plumbing, and broken fixtures and appliances. So this also goes to maintenance. It also goes to the fact that everything has a lifespan. A refrigerator needs to be replaced after a while. Homes are built in such a way as to, it's supposed to last forever in theory. It gives people a false sense of security about not fixing things because they think, well, that was meant to last a long, long time. Why should I mess with it? All right, number 4, heating systems. Problems in this category include broken or malfunctioning operation controls, blocked chimneys, and unsafe exhaust disposal. This was written in backwards order because unsafe exhaust disposal is like the most dangerous thing possible. If you're using a fuel source that involves combustion, natural gas, fire, heating oil, if there's a flame in your house, there are combustion byproducts, and those are toxic. The worst of which is carbon monoxide, which is produced if you don't get a clean burn. So this can happen with natural gas especially. But any combustion byproducts, they need to be vented outside the house. If they're not, you're putting the occupant's health at risk. When you have a blocked chimney, there's the possibility of what's called a puffback, meaning you light a fire and all the smoke you're generating can't get through the restricted space, and so it comes actually back into the living room. What's even worse is if you have a chimney fire, as if that isn't bad enough. So because the soot that builds up in there, that may eventually burn. But anyway, the problems with heating systems, they can lead to the house burning down. When you have an open flame somewhere in the house, you have a flame in the house. So, people need to be worried about their pilot lights. And if the pilot light goes out when you're using natural gas, then the natural gas is building up without nothing burning it off, and you're creating a hazard for a potential explosion. So any combustible fuel is very dangerous for heating. I think homes of the future need to just get out of this. This is outside of the fact that fossil fuels need to go away for climate change reasons. Number 3, roof damage. Although reported by only 8.5% of the respondents as the most common problem, roof leakage caused by old or damaged shingles or improper flashing was considered by inspectors to be a frequent problem. This goes back again to the idea of homeowners are not given a user guide or a set of instructions on how to take care of their house. And roofs are very easy to overlook because of they're expensive to replace. It can be $20,000, $30,000 for a new roof. Sometimes you might go past people's houses and there's stuff growing on the roof. They've really let them go. If your roof fails, your whole house is at risk. So it's very important to take care of, but this is another area where homeowners are being set up to fail because it is an expensive upkeep, And when do you know when to do that? Number 2, improper electrical wiring. A significant number, 19.9%, chose this item as the most common home defect, which includes such situations as insufficient electrical service to the house, inadequate overload protection, and amateur and often dangerous wiring connections. You know, people think they can watch a couple of YouTube videos and they know how to wire a house. Electrical fires are actually the most common cause of home fires, not because of a fireplace or natural gas explosion. So if you're going to have any roof work done, hire a professional. If you're going to have any electrical work done, hire a professional. And the number 1 most common house problem, improper surface grading or drainage. This was by far the most frequently found problem, reported by 35.8% of the survey respondents. It is responsible for the most common of household maladies, including water penetration of the basement and crawl space. Water is the enemy of a foundation. Water carved out the Grand Canyon. Water, when it can get into molecular-sized crevices, over time, water freezing, the freezing process, water expands as it freezes. So when water gets into something and then freezes and it expands, whatever crack it got in just got bigger. That's why we get potholes in the road. You know, water and ice can break the road. So water penetration into the basement or into the foundation is very bad. If the foundation cracks, the whole house is at risk. So this is the way we build foundations today. Foundations today are mostly made of cement. There's going to be some or reinforced concrete. There's steel rebar that is likely added. So, but the cement alone, let's get into the climate change stuff. The cement industry, if it was a nation, would be the 3rd largest producer of greenhouse gases behind China and the United States. 8% of global carbon dioxide emissions comes from the cement production process. So if we're going to cut back on greenhouse gases, we need to cut back on cement production. So in part 3, I'll actually go into a different idea for how we approach building the foundation of a house. Some other things to be aware of with regards to how we build houses today. There are noxious fumes that we've come to accept in houses, and other dangerous things like asbestos. Building products today are allowed to contain up to 1% asbestos. Older buildings likely contain a lot more, but there's still asbestos being installed in some places. It's allowed to be put into ceramic tiles. I'm not quite sure what else, but it's still legal. Formaldehyde is not something you want to be smelling. That's that new car smell, new carpet smell, new drapes, the upholstery coming out of your couch. That smell is formaldehyde, and it is dangerous to be breathing that in. I've already mentioned combustion zones producing carbon monoxide. That's also very dangerous and shouldn't be in our homes. So if we build our houses differently, if we build our houses smarter, if we build our houses with a different approach to utilities, we can get away from all these dangers. We can get away from all these problems that home inspectors have been identifying. And so in the next video, I'll tie all this together, present a plan for how houses of the future could be built, get away from using any kind of combustible fuels, using recycled materials, having utility services that allow the houses to be off-grid, and also produce houses that are a lot more durable. So I'll wrap this one up here. Thank you very much for watching. If you liked, please click like below. If you have anything to say, any questions, feel free to comment. Please do subscribe to keep up to date with new videos as they come out. And I'll see you next time.